How can ReLU be so simple yet effective in neural networks? Imagine a switch that turns on when the input is positive and stays off when it is negative. That's essentially what ReLU does in neural networks. It's a straightforward function that takes any number and outputs it if it's positive, or 0 if it's negative. This simplicity makes ReLU incredibly fast to compute, which is a big plus when training large models. But why has this simple idea become so popular and effective? Well, it all comes down to how it helps neural networks learn better and faster. ReLU introduces nonlinearity into the network, which is essential for learning complex patterns. Unlike functions like sigmoid or tan that squash values into a small range, ReLU allows positive signals to pass through unchanged. This means the network can keep important information flowing without getting stuck or losing details. It also helps solve a common problem called the vanishing gradient. When training deep neural networks, gradients can become tiny, making learning slow or stopping altogether. ReLU's gradient for positive inputs is always 1, so it keeps the flow of learning steady through many layers. Another reason ReLU works so well is that it creates sparse activations. Since it outputs 0 for all negative inputs, many neurons stay inactive at once. This sparsity makes the network more efficient and helps prevent overfitting, which is when a model learns noise instead of useful patterns. Plus, ReLU's simplicity means it only needs a quick comparison to decide whether to output 0 or the input value. This makes it much faster than more complex functions that involve exponentials or other calculations. The linear behavior for positive inputs also makes optimization easier. When the network sees positive signals, it behaves almost like a linear model, which makes adjusting weights through gradient descent more straightforward. Because of these advantages, ReLU has become the go-to activation function for many deep learning tasks, from image recognition to language processing. Variants like leaky ReLU and parametric ReLU have been created to fix some issues, like neurons dying when they stop activating, but the core idea remains the same. Its simplicity combined with its ability to help neural networks learn complex things is what makes ReLU so effective and widely used today.